Battery. If capacitors are an extremely interesting electrical device used in electronic devices in order to modulate, for instance, current pulsation and so on, battery is another type of device that, from the other hand, is characterized with other features. So, for instance, we have in this case a really more important specifics energy with respect a quite pure power density, or in general specific power. This is due to the fact that here we have a lot of problems concerning electrochemical process, and so the capability to deliver energy is lower with respect the ones of capacitor. But from the other hand, in a battery in which electrochemical processes are present, in which we are using a spontaneous reaction in order to create electricity, the bulk and not only the surface of the electrodes are involved in the storings of energy, so we have something that can store really interesting amount of energy. So how said, when we're speaking about battery, remember the first lessons of this course, we're speaking about galvanic cell, or obviously only when we are speaking about primary cell, or in general when we're speaking about a battery during the discharging. During discharging process we are speaking about galvanic cell, and so we are exploiting the use of chemicals in a non-stable state that want to react in order to decrease their energy and so promote the formations of electricity. So we want to have something that can decrease its free energy, and by decreasing the free energy we can improve the generations of useful work, as we have described in thermodynamics. So basically in battery we have an electrical device that is based on the use of spontaneous chemical reaction. And in general, what is the structure of a battery? We know very well this, as battery is composed of two electrodes. It's composed of an anode, or a negative pole in general, associated with the electrode on which is proceeding the semi-reactions associated with the reduction potential that is smaller, remembering that electrons follow always the directions from a lower potential to an higher one. So basically this is the reason for which we have here a negative pole, because we are since this is a battery, and so since this is a spontaneous process, and since in a spontaneous process the pathway of the electrons follows these directions, it was obvious thinking about the fact that if electrons follow this direction, it means that this potential it will be smaller with respect to this one. Reasons for which this is known as let's write this circuit better. Okay. So what does it mean is that obviously this potential is probably smaller and this should be higher in order to ensure the working of the battery, because electrons should follow this trend. If electron during the discharging, during the spontaneous process transforming chemical energy in electricity are following this direction, that means that this potential is smaller than this one, and so this means that we can describe this electrode as the negative pole. In particular, during the discharging, obviously we have also the electrolyte inside in order to close the circuit. So electrode, the negative pole, electrode on the positive pole, and the electrolyte. During the discharging, the negative pole is an anode. Why? Because the anode basically means the place in which the oxidation is occurring. And since here we are removing electron from the species in order to discharge a current on the resistance and collect the same electrons in another place, here an oxidation is occurring since we are losing electron. So during the discharging, during the spontaneous discharging, we have that the negative pole is the anode and the positive obviously is a cathode. But if we are looking about rechargeable batteries, what is happening is that during the charging, so Imagine that we want to connect our battery on something that is able to polarize in an opposite way the two poles, basically also in according with what is an electrolytic cell. So a battery is acting as a galvanic cell during discharging and is acting as an electrolytic cell during charging when it's possible. So during charging we are applying an oppositional potential here in order to increase this potential and decrease this potential. Why? Because since we know that electrons are moving spontaneously from the smaller potential to the higher one, if we want to recharge the battery, we need to make the process and in the opposite direction. So we want to repristinate the original reagent. And so we want, if for instance the discharge leads to the formations of product B from reagent E, during the charging we want to reobtain the reagent from the product. And so we want to generate opposite directions of electrons. But the opposite directions of electrons can be created and ensured only if this potential is higher. And so we can apply a potentiometer in order to change the potential. So at the very beginning, during discharging, this potential is smaller and this is higher. And electrons want to jump towards higher potential. But during the charging, we are using a potentiometer, for instance the current of our house with the specific collector, and in this way basically we are doing this. We are increasing this potential and decreasing this one in order to ensure the opposite pathway and ensure also the opposite reaction. And so during the charging, what does it mean? Is that the anode, the negative pole is not anymore the anode, because now electrons are entering and so it's acting as a cathode, whereas the positive is acting as an anode. Some electrons are exiting. So even if the pole is still remain always the same, we can say that one electrode is acting as an anode or as a cathode in the case in which we are in discharging and charging. Don't make confusion about that. Since it doesn't mean that something is obviously an anode. It could be an anode and a cathode. We have this important difference. So now, with the last concept about introduction on battery, is the difference between primary and secondary battery. Why? Because we have described basically how it's possible sometimes to charge the batteries, so use an external potential in order to change the situation and ensure the proceeding of the opposite reaction, repristinating the reagent. Obviously this is not always possible, and because sometimes it's basically impossible to have the reversible reaction. We are generating products that are too much stable, or from cynetic reasons it's impossible to that, for instance the formations of insoluble oxide and so on. Well, in this situation, we will see, we're speaking about primary battery. And so primary batteries are not rechargeable batteries that in the moment in which the reagents are simply gone, the reactions start to be useless. Because it's basically we just need to dispose it, because we are not able to take advantage of any other energy from it. Whereas in the case of secondary battery, we are speaking about all that batteries that are rechargeable. Since maybe in that conditions, in the conditions in which these batteries are built, we are able, with applying an external potential, to represent the original situation. And so restart again with another discharge and proceed with different types of charging, discharging cycles. Obviously, every time we are proceeding such charging, discharging cycles, we are changing something in the batteries, and so after a certain number, the battery will die. But in general, this is extremely interesting, and it creates an extremely more green approach in the use of electricity. So we have primary battery non-rechargeable and secondary battery rechargeable. In the case of secondary battery, we need to focus our attention mainly in the descriptions of these devices. We will see, for instance, metal air battery, classical example is zinc air. We will see nickel cadmium, even if nowadays is not used a lot since it was quite toxic, and from the 19 is not used anymore, and now we are using nickel metal hydrate. We will see sodium sulfur battery, we will see lead acid, and we will see also fuel cell and lithium-ion battery and so on. So basically now we need to focus our attention on the different types of applications, so the different types of battery.